All right, this is section 8.4, areas of composite figures. So let's start. We've got a map here of the United States, and it says choose a few states and estimate the area in square miles. Which states' areas are easiest to find and which are difficult? So using the map key we have down here, so we're mixing a little bit of geography in with math, you can see that this whole length here is 500 miles. So if they've got this cut into, I'm counting 10 different slices, that makes each of these 50. So each of these squares is a 50 by 50 square. And so if we do 50 times 50, 5 times 5 is 25, followed by 2 zeros. So each of these squares is 2,500 square miles, just to give you an idea. So it's a 50 mile by 50 mile square. So if we look at Indiana, for example, we could try to count how many squares are in Indiana. So we've got 1, 2, I'm counting the full squares, 3, 4, 5, 6, 7, 8. I would say if you could combine some of these squares, like this right here might make a full square on bottom. This right here could make another full square. So we've got, that would be 10 total full squares. Maybe if you add these two together on the side here, you would get another square. So there's 11. I bet you if you added these together, we'd get close to a square. That's 12. Maybe these two here would be 13. If I added this one, this one, this one, you know, let's just say all of those make another square. So I think I counted 14 squares then. So I would do 14 times, and I know each of those squares was 2,500 square miles. And that gives you just about 35,000 square miles in the state of Indiana. And that's obviously a rough estimate because we were using partial squares. And then again, knowing that each square is 50 by 50. So 35,000 square miles would be the area. And remember we said in our last section that finding the area is like counting the squares inside of it. So that's literally what we're doing here. Indiana was a little bit difficult to do though because we had these partial squares, and Indiana is actually bordered by two rivers here. You can see on the Illinois side and then here on the Kentucky side. So states that would be easier to do are states like, Colorado would be incredibly easy to do, right? It does have partial squares, but Colorado itself is rectangular. So is Wyoming. And you can see me zoom out a little bit farther. So is Utah wouldn't be bad to do. New Mexico, Kansas wouldn't be bad at all. It's the states that are weird shaped, like Idaho, that would be hard to do up here. And maybe Michigan because it's got two parts to it. Those would be the states that are harder to do. But that's really what area is. It's finding the squares inside and the space inside. You can see just how big Alaska is compared to the rest of the United States. It's bigger than Texas, actually. So that's what the United States is made up of a bunch of different states, a bunch of different shapes, so you'd call it a composite figure. And we learned that a composite figure from last time was a shape made up by other shapes. All right, so let's look at these composite figures. Here we've got another grid, but these shapes will be a little bit easier to find than what those states were. And these unit squares are 1 by 1. So we're going to count how many squares we have. In this case, 1, 2, 3, 4, 5, 6, 7, 8. And another row of 8 makes 16. And 16 plus 8 is 24, plus another row of 8 would be 32. So far I'm just going to keep track of what we've got. We've got 32 squares. And then I start getting into half squares. So I'll just keep counting the full ones. We got 32 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I've got another one there I forgot about, so 13. So 12 plus 13, whoops, change that to red, gives us 45 full squares now. And then I've got a few half squares I have to count. Now remember, for perimeter, we said this was 1.5. And that's how long that little gold segment is. But I'm not finding perimeter anymore, so I'm not going to use 1.5. I'm finding area, which is just half a square. So these little triangles are half squares. So change color so I can keep them. This should be purple there. So then we've got 1 and 1/2, which are 1. Get 2 halves to make a 1, and then another 2 that make 2, and then I've got another 2 1/2 there. So plus 2 1/2 gives us, let's see, 45, so 47.5 units squared, or square units.
All right, for this second shape, we could do the same thing. We could count all the individual squares, but what would actually be faster for this is if we broke this into shapes that we know how to do. For example, if I just drew a line right here, I've split this shape into a square up here on the top and then a trapezoid down here on the bottom. And I know how to take the area of both these shapes, so that's going to save me time, because if you just try to count the squares, look at these partial squares right there, that those will be really hard to count. So if we're trying to find the area of a square, obviously we know it's length times width, or base times height. So 2 times 2 gives us 4. Obviously you can count that. And then for a trapezoid, the trapezoid formula is 1/2 base 1 plus base 2 times the height. And that's how we'll find the area of this trapezoid here. So the base 1 is 1, 2, 3, 4, 5, 6, 7, 8 units long. And we already know base 2 is 2 plus this other one right here makes it 3. And then the height is 1, 2, 3, 4, 5, 6. So now I've got all the numbers I need to plug in. So 1/2 plus 8 plus 3, or 1/2 times 8 plus 3, times the height, which is 6. So I'm going to go ahead and simplify a little bit. I know half of 6 is 3. I know 8 plus 3 is 11, so I'm just doing 11 times 3, which is 33. So there's 33 full squares in this trapezoid. Don't forget the 4 that we had up here, and that gives us a combined area of 37 units squared. So to find the area of a composite figure, one of those figures that's made up of different shapes, we're just going to combine the areas of the shapes that we already know. Okay, so in the last example, trapezoid and a square. In this example, it says find the area of the portion of the basketball court that's shown. And this is made up of, you can see a rectangle here, and then a semicircle. Now I know you're thinking this is a full circle, but if I include this portion of the semicircle as part of the rectangle, then I don't want to count it twice. So I'm just going to think of this as a rectangle and a semicircle. So let's start with the rectangle. The rectangle is 19 by 12. And 19 times 12 is 228. So that is the area of this rectangle here. And then we've got a semicircle. So for the semicircle, we know a full circle would be pi times the radius squared. So for a semicircle, we're just going to do half of that, right? We only have half a circle. So the radius, if this distance here is 12, that makes the radius 6. So I only want this portion here, which is 6. So 1/2 times pi times 6 squared. So that's going to be 1/2 times pi, and then 6 times 6, or 6 squared, is 36. And I can multiply all this together. I know half of 36 just means 36 divided by 2, so that's 18 times 3.14 is 56.52. And that's feet squared. And then we're just going to combine that with the rectangle. So we have the semicircle part here, we've got the rectangle part here, and we're just going to combine the two. And if you add 228 back on, that gives us a total area of 284.52, and that's going to be feet squared. So again, we just add up the shapes that we know. We know how to take the area of a semicircle, we know how to take the area of a rectangle. All right, let's look at a few more examples. In example A, we've got a parallelogram with a rectangle and then also a triangle. So we have 3 shapes, and we know how to take the area of all 3 of them. For the parallelogram, down here on the bottom, we do base times height. Okay, so 8 times 6.7 is going to give us 53.6. And that's pretty easy to find that. For the rectangle up here, we know rectangle is also base times height. So 8 times 4.5, and 8 times 4.5 is 36. And then for the triangle, we do 1/2 base times height. So 1/2 times 11.2 times the height, which is 4.5. Again, 4.5, right? There's the height, there's the base. So 11.2 times 4.5 divided by 2, which remember taking half is the same as dividing by 2, is 25.2. And then I just add those three shapes together. So 25.2 plus 53.6 plus 36 gives us 114.8, and this is centimeters squared. And the second example here, we've got a rectangle and a triangle. And really just one triangle, right? This is just a triangle right here. So for the rectangle, 9 times 7, we know is 63, so base times height. And then for the triangle, 1/2 times the base. Now, the base here is going to be the other side of the rectangle, so that's going to be 9 times the height, which is 6. So I could, instead of doing half of 9, I could do half of 6. Half of 6 is 3, and 3 times 9 is 27 meters squared. So I take 27 for the triangle, I take 63 for the rectangle, I add them together, and 27 plus 63 is 90 meters squared. All right, example C, we did a shape similar to this with the hotel pool problem we did in our practice quiz. And in a practice quiz, we were finding perimeter, so we don't have to worry about these circles. But now we have to worry about that square in the middle as well. So we have 4 semicircles and then a square. Let's just go ahead and do the square. The square is 2 by 2, and 2 times 2 is 4. So that's easy, that's the square. Now, for this 4 semicircles, remember that 4 halves make 2 full circles. So there's one circle and there's another circle. So, and they're all the same size, right? So I don't have to take half. I know 4 halves makes 2 whole circles. So I'm going to do pi r squared, and I'm just going to double it, and that'll give me 2 full circles. So if the diameter is 2, you can see the diameter here is 2 feet, then that means the radius is going to be 1. So 2 times pi r is 1 squared. And 1 squared is 1, and 1 times 2 is 2, so this is just the same as 2 pi, and 2 times 3.14 is 6.28, and that includes our 2 circles. So I add those together, and that gives me a total combined area of 10.28 feet squared. And then example D, we've got a triangle, we've got a rectangle, and we've got a trapezoid. So 3 shapes again. Let's start with the triangle. The triangle, we're going to do 1/2 times its base times its height. Now it says here the base is 4. So 1/2 times 4, and then the height we know is 5, right? That's 5 there. So half of 4 is 2, and 2 times 5 is 10. For the rectangle, it's 5 by 9. So 5 times 9 is 45. So of course I'm going to add those together. And then for the trapezoid has the formula 1/2 times base 1. Now the first base is 9, plus base 2. Second base is 6.4 times the height, which it is also 5. The height's been 5 for all of these. So 9 plus 6.4 is 15.4. Now I'm going to times that by 5, and I'm going to divide it by 2. So times 5 divided by 2 for the half, and that gives us 38.5. And I just add these together. Put a plus sign right there. 10 plus 45 plus 38.5 is 93.5, and that's inches squared for this problem. So that's how you take the area of composite shapes. You just add up all the areas of the shapes you do know how to take the area of. All right, let's do one more example that has a circle or a semicircle here. So for this example, it says the figure of, find the area of the pool and the deck. The figure is made up of a right triangle, a square, and a semicircle. So here's the right triangle. If I can get it highlighted here. There's the right triangle. And then a square. The square I can see as well. Now that circle, part of the circle is incorporated in the shape of the square. So then I've got a semicircle right here, and I'm going to find the area of all three of those shapes. So let's start with a triangle. 1/2 times the base, 10, times the height, which is 24. Half of 24 is 12, and 12 times 10 is 120. So that's an easy way to do that in your head. For the square, it's 26 by 26, obviously. It's a square, so 26 squared. 26 squared is 676. And then for the semicircle, pi r squared. Now, if the diameter is, right here, if the diameter is 26, that means the radius must be 13. So pi times 13 squared. And then I'm going to do half of that because it's only a semicircle. So 13 squared, 169, times 3.14, divided by 2, because it's a semicircle, is 265.33. And I'm using 3.14 for my pi in all my calculations. So that gives me a final answer. If I add all these up, add 676, add 120 onto that, and that gives me 1,061.33 feet squared. And I like this homework because, again, it just takes the shapes I already know, and it's not really anything new. It just takes the shapes I already know, and we just take the area of all of them and combine them together by adding. So if you have any questions, let me know.